Now see, we discussed this thing. For a capacitor, the capacitance of capacitor that is given by C equal to Q by V. Okay. Now here one simple question arises in our mind. Can we deposit infinite amount of charge on the capacitor? Means, can we increase the capacitance of the capacitor as per our desire? Then the simple answer, no. Why? See, as we increase the charge on the capacitor, then electric field between two conductors becomes stronger and stronger. Now between two conductors there is the dielectric medium. That is with certain dielectric strength. Dielectric strength of dielectric substance means the maximum electric field strength up to which it remain dielectric, and after that, if the electric field strength increases, then its ionization takes place and it becomes conductor. એટલે આપણે સિમ્પલ એક્ઝામ્પલ લઈએ કે પેરેલલ પ્લેટ કેપેસિટર છે આપણી પાસે, એની વચ્ચે એર છે, and suppose continuously we are increasing the charge on the capacitor, then definitely after a certain electric field strength, the ionization of air molecules will take place, and now it will become conductor and the leakage of charge will take place. It implies that now suppose we want to increase the capacitance of capacitor, then what we have to do? Clear to all of you? Now, with experimental observations, scientists came to know about this thing. If dielectric substance is placed between two plates of the capacitor, then its capacitance can be increased. So now we have to understand this thing, how the capacitance of the capacitor can be increased using dielectric substance. Okay. Now see, suppose we have a parallel plate capacitor as shown in the figure. Charge on the capacitor, that is Q, it implies that on the positive plate, or we can say positively charged plate, charge is plus Q and its surface charge density, that is sigma. On negatively charged plate, charge is minus Q and surface charge density, that is minus sigma. Electric field between two plates of the capacitor, that is E0 equal to sigma upon epsilon 0. Then potential difference between two plates, that is E0 into D, and capacitance of capacitor, that is epsilon 0 A by D. Okay. Now this one is the situation when dielectric substance is not introduced between two plates of the capacitor, means we can say there is a vacuum. Clear? Now if dielectric slab is introduced between two plates of the capacitor, then we already discussed about the polarization of dielectric substance in external electric field. So we can say here the dielectric slab is now in the electric field of capacitor. So on the surface of the dielectric slab, which one is close to the positive plate of the capacitor, negative charge will be induced, and the surface of the dielectric slab, which one is close to the negatively charged plate of the capacitor, there positive charge will be induced. So here the surface charge densities after polarization of the substance at the surfaces of the dielectric slab are sigma p and minus sigma p. So inside the dielectric slab, the electric field developed, that is sigma p upon epsilon 0, and that will be in the opposite direction of electric field of the capacitor. Clear to all of you? Now the resultant electric field E, that is equal to E0 minus EP. So we can write E, that is equal to E0 is replaced by sigma upon epsilon 0, and EP is replaced by sigma p upon epsilon 0. Now if we take here epsilon 0 LCM, then simply we can write E, that is equal to sigma minus sigma p upon epsilon 0. This is the net electric field in the capacitor. Clear? Now, experimentally we can observe this thing. This sigma minus sigma p, that depends on sigma. Here, this one is very simple thing. As sigma is larger one, it implies that charge on the capacitor is more than electric field between two plate of the capacitor, that will be stronger one. And due to that, the polarization of the dielectric substance introduced between two plate of the capacitor, that will be more. Clear? It implies that now we can say this thing as sigma is increased, here sigma minus sigma p also increases. So we can write sigma minus sigma p when depends on sigma. So if we introduce here proportionality constant, then experiments shows this thing that proportionality constant, that is 1 upon k, where k, that is the dielectric constant of that dielectric medium. Clear? So now in this particular equation of the net electric field, if we replace sigma minus sigma p by sigma upon k, then we can write net electric field E, that is sigma upon k epsilon 0. But sigma upon epsilon 0, that is E0, here we discussed initially. So we can write E equal to E0 by K. It implies that here we can conclude like this: when dielectric slab having dielectric constant K is introduced between two plate of the capacitor, the electric field between two plate of the capacitor is reduced by 1 upon K times. Clear? Than the original one. Now the potential difference between two plate of the capacitor, that we can write V equal to E into D. E, that is sigma upon K epsilon 0 D. So here the potential difference also becomes 1 upon K times then the initial one. Now if we replace this sigma by Q upon A, then we will get the equation V, that is equal to Q upon K epsilon 0 A whole thing, that is multiplied by D. Clear? Now as per definition of the capacitance, we can write capacitance of the capacitor, that is Q by V. So here from this equation we can write Q by V, that is equal to epsilon 0 A by D into K. But epsilon 0 A by D, that is the original capacitance of the capacitor when dielectric slab was not introduced. So that is C0. So we can write the new capacitance of the capacitor after the dielectric slab is introduced, that is C0 into K. So here we can conclude like this: when the dielectric substance of dielectric constant K is introduced between two plates of the capacitor, its capacitance, that is increased by K times. Clear to all of you? Now in chapter number 1 we discussed this thing, the dielectric constant K of the medium, that is nothing but its relative permittivity, means that is the permittivity of the medium with respect to that of vacuum. Clear?